You are welcome to Science Tutorials with Farmeternity the Schoolboy. Today we are going to take a look at chemistry. Today we have a question that says, what is a standard solution? What is a standard solution? A standard solution is a solution with a known exact concentration. What it means is that if a solution has a known exact concentration, that solution is what? A standard what? Solution. There are two types of standard solution. We have primary standard solution and secondary standard solution. Then let's start with primary standard solution. What is a primary standard solution? A primary standard solution is a solution that is produced from where? From a primary standard. What is a primary standard? A primary standard is a highly pure and stable chemical reagent. It is less reactive and less hygroscopic. It is less reactive because of what? Because it is highly pure. The purity is about 99.9%. So it's a very, very pure substance. Because of that, it tends to, have less reactivity. What it means is that if you weigh a specific amount, say 10 gram of a primary standard, you are sure that it contains 10 gram or approximately 10 gram of the pure substance. That's what it means by what? By having a high what? Purity. Now, what are the examples of this primary standard? Examples are sodium triisocarbonate form, potassium heptaoxodichromate 6. These are examples of what? Examples of what? Primary what? Standards. Now, how do you now produce a primary standard solution? A primary standard solution is prepared by dissolving a specific amount of a primary standard in a little volume of solvent, example water, then making it up to a required volume. And once you do that, you have produced a primary standard, because the concentration can just be determined by dividing the amount of the primary standard that you used by the entire volume of the solution produced. Once you do that, you have determined the concentration of the solution prepared from a primary standard. This makes it a primary standard what? Solution, because you have determined the exact concentration. It is exact because you are sure that this concentration actually gives you the actual concentration of the substance, the primary standard in that solution, because you are sure that the purity is almost 100%. Now, examples of primary standard solution. Examples are, you can x mole per dm cube of sodium triisocarbonate 4 of volume say ycm cube is a primary standard solution. A solution say ycm cube of x mole per dm cube of potassium heptaoxodichromate 6 is an example of what? Primary what? Standard. Now, primary standard are actually used to standardize a given solution. What it means is this: by standardization, primary standard can be used to determine the concentration of other solutions. Once you get a specific volume of a primary standard solution and titrate it with a volume of another solution of unknown concentration, you can use it to actually determine the concentration of that what solution. We'll talk more on that when we get to secondary standard solution. That's all for now on primary standard solution. You can research more on this solution. Now, let's go to secondary standard solution. Secondary standard solution. What is a secondary standard solution? A secondary standard solution is a solution produced by standardizing a given volume of a solution of a secondary standard. If you prepare a solution of a secondary standard, once you standardize it using a primary standard solution, you have produced a secondary standard solution. I repeat, if you prepare a specific volume of a solution and titrate it or standardize it with a primary standard solution, you have produced a secondary standard solution. Now, what is this? What is now secondary standard? A secondary standard is a chemical reagent that is less pure. It has impurities. It's very, very reactive because its reactive nature makes it to have impurities and is very, very hygroscopic. Yes, it is highly hygroscopic. Now, unlike in primary standard, if you weigh a specific amount of a primary of a secondary standard, you are not sure that it is 99.9 or even 100% pure. Why? Because it has impurities. So if you use such substance that has impurities and dissolve it in water or any other solvent, you can decide to calculate the concentration the way you did when you are determining the concentration of the primary standard solution. You have issues because you can never get the concentration because you are not sure of the actual amount of the pure substance in the solution. That's why you cannot produce a secondary standard solution by mere dissolving a secondary standard in a solvent. No, you cannot. The only way to do that is to do what? Titrate the solution you produce with a primary standard solution. You cannot determine the concentration. So this is what happens in what? Secondary what? Standard solution. Now, through this titration, you get whatever you are looking for in terms of determining the concentration of a what? Secondary standard what? Solution. Now, how do we now carry this thing out? Let me now throw more light on that. You know, if you have already gotten your primary standard solution, a given volume of primary standard solution, of course, you know the concentration because, of course, you cannot call it a standard solution without knowing the concentration. So if you, for a primary standard solution, you have already gotten, you measure a particular volume and you know the concentration. Now you keep it. You now prepare, use a secondary standard. Prepare a solution of a secondary standard of known volume. Then you titrate the secondary standard with primary against the primary standard. If you do that, actually you are carrying out a reaction. The only species of the secondary standard that will react with the primary standard is the pure secondary standard that will react. The impurities will not react with the primary standard. Is the pure form of the secondary standard that will react to the primary standard. And when this happens, you can now use the mole ratio to determine the actual concentration of the secondary standard that reacted. And when you do that, you have actually determined the concentration of the secondary standard in that solution. thereby standardizing the what? The solution. This is obtainable in the formula from our popular formula where we say that C A, for example, now V A over C B V B is equal to what? N A over what? N B. C is the acid, constitution of the acid. Let's assume that this A represents the standard solution, the primary standard. B, the one downstairs, the B represent, for example, now the secondary solution prepared from a secondary standard. As you can see now, you already know the concentration of the primary standard solution. You know the volume you are using. In the reaction, you know the mole ratio. You know the number of moles of the primary standard that reacted. Now, CB now, let it now represent the concentration of the solution of secondary standard. You don't know the word concentration, so there's question mark here. VB is the volume of the solution of the what? Secondary standard you use. Then MB is the number of moles that reacted. If you make this CB now the subject of the formula, you can now see that you can actually calculate the concentration of the what? The solution of the secondary what? Standard. Solution of the what? Secondary standard. Once you do that, you have determined the concentration, and that will make it a secondary standard solution. That means you have standardized it. So this is what happens. This is how to produce a secondary standard solution. You cannot produce using the same method of production of primary or preparation of what? Primary standard solution. No, it cannot work. Now, actually, secondary standard solution is produced for a specific purpose, for a specific analysis. You produce secondary standard solution. Examples of secondary standards are anhydrous sodium hydroxide, then potassium permanganate. Yes. Then that means the examples of secondary standard solutions are now solutions of these sodium hydroxide and potassium permanganate of specific volume and specific concentration. So we'll stop here for today. If you have any question, feel free to chat me up on WhatsApp. The WhatsApp number is on the screen. You can subscribe to our YouTube channel. You can subscribe to my personal YouTube channel from Eternity the Schoolboy. You can subscribe to Susan Academy. You can even subscribe to Susan Limited. All on YouTube. You watch our lectures. Thank you very much for your attention. My name is from Eternity the Schoolboy. See you next time.